An industrial electronics technology program provides a comprehensive understanding of electrical principles, circuits, and systems, a foundation essential for any electrician. Residential work often involves troubleshooting electrical problems, and the advanced techniques taught in the program can equip you to efficiently diagnose and repair issues. Many modern residential systems incorporate automation and control elements. The program's focus on industrial automation and control systems will give you a competitive edge in understanding and servicing these technologies. The residential electrical market is highly competitive, and having an industrial electronics technology degree can differentiate you from other candidates and open up more job opportunities. However, the program may not cover all the specific codes and practices required for residential work. You may need to supplement your education with additional training or experience. An associate's degree in industrial technology may be an overqualification for some residential positions, but it can still demonstrate your commitment to the profession and your ability to handle more complex electrical systems. If you plan to focus solely on residential work, an industrial electronics technology degree may be more than necessary, but it can still provide a strong advantage. Review the coursework to ensure that it aligns with your goals. If necessary, consider taking additional courses or certifications that specifically focus on residential applications. Connect with people in the residential electrical field to get their insights on the value of an industrial electronics technology degree for their work. A career counselor can help you assess your goals and determine if an industrial electronics technology degree is the right fit. Overall, while an industrial electronics technology degree may not be strictly necessary for residential work, it can provide a valuable foundation and differentiate you from other candidates. It's important to weigh the potential benefits and drawbacks carefully before making a decision. Now, let's delve into some of the specific electrical concepts you might encounter in both industrial and residential settings, drawing parallels and highlighting differences. One fundamental concept is Ohm's law, which states that voltage equals current times resistance. This applies universally. Whether you're calculating the current flowing through a motor in a factory or the current through a light bulb in a home, Ohm's law remains the same. Similarly, the principles of series and parallel circuits are crucial in both environments. Understanding how components are connected and how current and voltage behave in each configuration is essential for troubleshooting and design. The National Electrical Code, or NEC, provides the standards for safe electrical installations. While the NEC covers both industrial and residential applications, certain sections are more relevant to one than the other. For example, Article 210 deals with branch circuits, which are commonly used in residential wiring. Article 430 covers motors and motor circuits, which are more prevalent in industrial settings. However, many general requirements such as grounding and overcurrent protection apply to both. Grounding is a critical safety measure designed to protect people from electrical shock. In both residential and industrial systems, grounding provides a low resistance path for fault current to flow back to the source, causing the overcurrent protective device, such as a circuit breaker or fuse, to trip and energize the circuit. Overcurrent protection is another essential safety feature. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a safe level. This prevents overheating of conductors and equipment, reducing the risk of fire and electrical hazards. Wiring methods differ between residential and industrial settings due to the different environments and requirements. In residential wiring, non-metallic sheath cable, often referred to as Romex, is commonly used for branch circuits. In industrial settings, conduit, such as rigid metal conduit or electrical metallic tubing, is often preferred for its durability and protection against physical damage. Control systems play a significant role in both industrial and, increasingly, residential applications. In industrial settings, programmable logic controllers, or PLCs, are used to automate complex processes. In homes, smart thermostats, lighting controls, and security systems are becoming increasingly popular. Understanding the principles of control systems, including sensors, actuators, and feedback loops, is valuable in both fields. In industrial electronics, you'll likely encounter three-phase power systems, which are used to power large motors and equipment. In residential settings, single-phase power is the norm. However, understanding three-phase power can be beneficial, especially if you're working on larger residential projects that may incorporate three-phase appliances or equipment. When troubleshooting electrical problems, it's essential to have a systematic approach. Firstly, gather information about the problem. What are the symptoms? When did the problem start? Has anything changed recently? Secondly, use your knowledge of electrical principles and circuits to develop a hypothesis about the cause of the problem. Thirdly, test your hypothesis using appropriate test equipment, such as a multimeter or clamp meter. Firstly, verify that the power is off before working on any electrical equipment. Secondly, follow proper lockout/tagout procedures to prevent accidental energization of the circuit. Thirdly, use appropriate personal protective equipment, such as safety glasses and insulated gloves. Motors are used extensively in both industrial and residential applications. Understanding the different types of motors, their operating principles, and their control methods is essential for both fields. In industrial settings, you might encounter large three-phase induction motors. In homes, you'll find smaller single-phase motors in appliances such as refrigerators, washing machines, and air conditioners. Safety is paramount when working with electricity. Adhering to the NEC and following safe work practices is essential to prevent accidents and injuries. Firstly, always assume that a circuit is live until you've verified that it's de-energized. Secondly, never work on electrical equipment when you're tired or distracted. Thirdly, if you're not comfortable with a particular task, seek help from a qualified electrician. As you progress in your industrial electronics technology program, take advantage of opportunities to gain hands-on experience. Participate in lab exercises, work on projects, and seek out internships or apprenticeships. The more practical experience you gain, the better prepared you'll be for your career. Consider supplementing your education with additional training or certifications that specifically focus on residential applications. For example, you might take a course on residential wiring methods or obtain certification as a residential electrician. Stay up to date with the latest technologies and trends in the electrical field. Attend industry conferences, read trade publications, and participate in online forums. The electrical field is constantly evolving, so it's important to continue learning throughout your career. Networking with other electricians can provide valuable insights and opportunities. Attend local chapter meetings of professional organizations such as the International Association of Electrical Inspectors, or IE, and connect with electricians on social media platforms. As the integration of renewable energy sources such as solar panels and wind turbines becomes more common, electricians need to understand how to install and maintain these systems. The NEC has specific articles that address renewable energy systems, such as Article 690 for solar photovoltaic systems and Article 694 for small wind electric systems. As technology advances, homes are becoming increasingly connected, with smart devices controlling everything from lighting and temperature to security and entertainment. Electricians need to be able to install and troubleshoot these systems, which often involve networking and communication protocols. Electric vehicle charging stations are becoming more prevalent, and electricians need to be able to install and maintain them. The NEC has specific requirements for electric vehicle charging equipment, which are covered in Article 625. In industrial settings, variable frequency drives, or VFDs, are commonly used to control the speed of motors. Understanding how VFD work and how to troubleshoot them is an important skill for industrial electronics technicians. Programmable logic controllers, or PLCs, are used to automate complex processes in industrial settings. Learning how to program and troubleshoot PLC is a valuable skill for industrial electronics technicians. Industrial robots are used in a variety of manufacturing processes. Understanding how robots work and how to maintain them is becoming increasingly important for industrial electronics technicians. In industrial settings, preventative maintenance is essential to keep equipment running smoothly and to prevent breakdowns. This includes regularly inspecting equipment, lubricating moving parts, and replacing worn components. Electricians play a key role in ensuring that electrical systems are energy efficient. This includes using energy-efficient lighting, optimizing motor performance, and reducing standby power consumption. Electricians need to be familiar with the different types of test equipment used to troubleshoot electrical problems, such as multimeters, clamp meters, insulation resistance testers, and power quality analyzers. Understanding electrical drawings and schematics is essential for electricians. These drawings provide a visual representation of the electrical system and show how the different components are connected. Electricians need to be able to read and interpret these drawings to install, troubleshoot, and maintain electrical systems. Electricians must be knowledgeable about the NEC and other applicable codes and standards. They need to be able to apply these codes and standards to ensure that electrical installations are safe and compliant. In addition to technical skills, electricians also need strong communication and interpersonal skills. They need to be able to communicate effectively with customers, coworkers, and other professionals. They also need to be able to work effectively in a team environment. Many electricians start their careers as apprentices, working under the supervision of experienced electricians. This allows them to gain hands-on experience and to learn the trade from seasoned professionals. Electricians can advance their careers by becoming licensed master electricians or by specializing in a particular area of expertise, such as industrial automation or renewable energy. The demand for skilled electricians is expected to grow in the coming years. This is due to a number of factors, including the aging infrastructure, the increasing use of electricity, and the growing demand for renewable energy. An industrial electronics technology degree can provide a solid foundation for a career as an electrician. The program covers a wide range of electrical topics, including electrical theory, circuit analysis, motor controls, and programmable logic controllers. However, it's important to supplement your education with additional training and experience to prepare for the specific requirements of residential or industrial work. Residential electricians typically work on smaller projects, such as wiring homes and apartments. Industrial electricians typically work on larger projects, such as wiring factories and power plants. Both residential and industrial electricians need to be able to read electrical drawings, install wiring and equipment, and troubleshoot electrical problems. Residential electricians need to be familiar with the NEC requirements for residential wiring. Industrial electricians need to be familiar with the NEC requirements for industrial wiring. Both residential and industrial electricians need to be able to work safely and efficiently. To become a licensed electrician, you typically need to complete an apprenticeship program and pass a licensing exam. The requirements for licensure vary by state and locality. Once you're licensed, you can work as an electrician on your own or for an electrical contractor. The electrical field is a challenging and rewarding career. Electricians play a vital role in ensuring that our homes and businesses have safe and reliable electrical power. With the right education, training, and experience, you can have a successful career as an electrician. To further enhance your knowledge, consider exploring specific sections of the NEC that pertain to residential and industrial applications. For residential work, focus on articles such as 210, which covers branch circuits, 220, which deals with calculations for services, feeders, and branch circuits, and 250, which addresses grounding and bonding. Understanding these articles will help you ensure that your residential electrical installations are safe and compliant. For industrial work, focus on articles such as 430, which covers motors, motor circuits, and controllers, 480, which addresses storage batteries, and 500 through 516, which cover hazardous locations. Familiarizing yourself with these articles will help you understand the specific requirements for industrial electrical systems. Also, remember to consider the location and environmental factors when designing and installing electrical systems. For example, in damp or wet locations, you'll need to use waterproof or weatherproof enclosures and fittings. In hazardous locations, you'll need to use explosion-proof equipment. Firstly, remember to use the right tools for the job. Secondly, take the time to do the job right the first time. Thirdly, always double-check your work to ensure that it's safe and compliant. By following these tips, you can minimize the risk of errors and ensure that your electrical installations are safe and reliable.